So our first guided practice is that we want to find the area of the curve y equals 20 minus x squared, bounded with the x-axis. So we want to draw a sketch of this quadratic first. Now we've got a negative quadratic, so we know we're going to have that upside down shape. We just need to find the roots and know that my y-intercept is going to be 20. So to find my roots, I am going to factorise it. So I'm looking at my factors of 20, which make a sum of -1, but we must have a negative x and a positive x to get that negative x squared. So I must have a 4 here and a 5 there, because I've got negative 5x plus positive 4x to get me that negative 1x here. So my roots are going to be 5 and -5. My y-intercept is going to be 20, and we're going to have that upside down quadratic shape, that negative quadratic shape. So it's going to look something like so. I've got a root at 4, one at -5, and my y-intercept at 20. I want to find the area between this quadratic and the x-axis. So the x-axis, that's our horizontal axis. So I want to find the area of that. So I'm going to be integrating the curve between the values -5 and 4. So I'm going to be calculating the area, which is the integral between -5 and 4 of 20 minus x squared. So I'm going to integrate each term first, put them in my square brackets. So I've got 20 integrated is 20x, minus x to the power of 1, so we're adding 1 to the power, so I know that I'm going to get x squared, and then dividing the coefficient by that power. So we've got 1/2. Here I've got negative x squared, I'm going to add 1 to the power, so I'm going to have negative x cubed, and then I'm going to divide my coefficient by that power, so I get 1/3. And we're integrating that between -5 and 4. So when I substitute in x equals 4, 20 times 4, that is 80. A half times 4 squared, that's a half times 16, which is 8. A third times x to the power of 3. 4 to the power of 3 is 64, and then we want a third of that. And I'm then going to subtract the integral when x equals -5. So you can just use your calculator for this. 20 times -5, that's -100. A half times -5 squared, that is 25/2, but we're subtracting that. And then I'm subtracting a half x to the power of 3. Now -5 to the power of 3 is -125. So this is going to become a positive. We've got 125/3. And my answer is 243/2. We're now going to look at finding the area bounded by a cubic graph and the x-axis. So we're going to have to look at the area above the x-axis and below the x-axis. So the first thing we're going to do, as usual, is draw a sketch. So we're going to have our y-axis, our x-axis. Now this sketch does not have to be incredibly accurate, this is just helping you understand the different values you need to take when you're integrating. So we've got our x-axis, our y-axis, and we want to draw this cubic here. So it's already been factorised for you, which means we can read off the roots really easily. So the first root here, we've got x equals 0. Second root is when x equals 1. And the final root is when x equals negative 3. We've got a positive cubic graph, so it's going to be of this form. So we've got our root at 1, our root at 3, and our root at 0. We want to find the area bounded by this curve and the x-axis. So we want to find the area of this part of the curve and the area of this part of the curve. Now, if we were to integrate our curve from 3 to 1, because this bit here would give us a negative value, we would end up with this part of this area, subtract that area, which isn't what we want. We want this area plus that area. So what we're going to do, we're going to split up our integration. So we're going to first of all integrate our curve between the values, that should say negative 3, between the values negative 3 and 0. And then we're going to add the area from 0 to 1. So we've split this up so that we get this area, add that area, because we know that that's below x, so when we integrate it, it's going to become negative, and we don't want any cancellations. Now, before we start integrating, we've got a factorised cubic here, so we can't integrate it term by term at the moment, so we're going to have to expand those two brackets. So if we look at our cubic, we've got y equals x times x minus 1 times x plus 3. If we expand those brackets, we've got x squared plus 2x minus 3. Then we want to multiply the bracket by x, and we get x to the power of 3 plus 2x squared minus 3x. So I'm going to rewrite the integration that I want to do now. So remember, we're doing it in two parts. We're doing it from negative 3 to 0 first, and then we're doing it from 0 to 1. Oops. 2x squared minus 3x dx. Just ignore that bracket. I'm going to start integrating. So adding 1 to the power, dividing it. 2 plus 1 is 3. 2 divided by 3, 2/3. 1 plus 1 is 2. 3 divided by 2, 3/2. Then from minus 3 to 0. And then I'm going to do the same from 0 to 1. So, first of all, when we substitute in 0, each of these terms is going to become 0. So the first part of this integration is equal to 0, and then we're subtracting this expression when x is equal to negative 3. So when x is equal to negative 3, I get 81 over 4 for that first term, subtract 2/3 times 27, subtract 3/2 times 9. Then for this part of the integration, we're going to first of all substitute in x equals 1. Now when x equals 1, each of these terms just becomes a coefficient. So we've got 1/4 plus 2/3, subtract 3/2, and then I'm going to subtract this expression when x equals 0. Now when I substitute x equals 0 into each of these terms, that just becomes 0. So putting this bracket here into my calculator, that is 45/4. If I put this bracket into my calculator, that is equal to negative 7/12. So like I said, we've got a negative value for this area here because it's underneath the x-axis. So all we do is take the positive version of that, because in areas, we know that areas are never negative. So we're doing 45/4 plus 7/12, which is 71/4.